Okay. So last class we have discussed about the states, STP state. We have learned like how is the disable state, what is the disable state. Then we moved into blocking state, then listening, then learning, then forwarding, right? So uh, so state was complete, right? So you have seen in disable state, no MAC address was learning, no BPDU, and sending and receiving. There is no MAC address table is building, right? Then we learn about the blocking state. In blocking state, you have seen there is no BPTU is sending, but it is receiving. Then second, no MAC address is learning, no data forwarding is happening. Only BPTU is receiving on this blocking port. Whatever you can see, this is the blocking port. It will receive the BPTU, but it will not process it. Okay, because we have alternate path, that is a root port we have already, and it's sending the BPDU and other communication, other things, right? So there is no mean like process that packet until unless this port went down. So we have a couple of port roles. Port roles, what is mean by port roles? For example, what is the state you know already, right? State means either it will disable, it will blocking, or it will be learning, it will be listening and learning. Like first listening will come and after that learning will come. Then we have a forwarding, right? So these are the state. But we have a something known as a uh, you know port roles in a spanning tree. Means if we have any port like in forwarding state, right? For example, it's forwarding means you can understand, right? You know already. Forwarding means it's forwarding the information. All type of frame is going to process it, right? So in that case, what will be the port role? What state is different thing? What will be the port role? This port role. It could be right, could be TP. DP also will be in forwarding. RP also will be forwarding state, right? And one more port roles you will see, that is alternate, ALT. So this is alternate port. Once you will see blocking state, right? BLK, blocking. Then port role you will see as a alternate. For the DP as well, I will explain more about once we will discuss about the RSTP. Then we will discuss, alternate port role and backup port roles. That I will explain what I mean by backup and what I mean by alternate. That's okay. But here in spanning tree, you will see only three types of port roles. I will prove that one. For example, in one switch, here is switch, and you will log in. Already you will log in last class only. So it is spanning tree. Once you will run, you will see this is the role, right? This is state. Okay. So state, what is the role? State will is look like state should be something blocking, forwarding, disable, and something blah blah. You have learned already, right? What will be the role? So you will see only three rules. Either you will see DP port, either you will see root port, or else you will see as a alternate. As explained, alternate means role state is blocking, then you will see alternate. If port role will be forwarding, it could be a root port or could be DP. Clear? More than three role you will not see in the spelling. Clear? Clear?
Yes. Yes.
Okay. Anurag,
Yes.
one more person willing to join today. That you
Yeah, I
send
told
the.
him. I
So
told
he's joining or how it is?
I told him, but he's not there.
Could you please call him if possible for you? And we
हमारे
are going.
रोल्स कर दो ROLES. ROLES.
ROLE. Okay. Four rows in Spanish. So first was like DT, second is RP, third is A, LTR, alternate, right? These are the only three code rows we will see in Spanish. Okay, clear, right? Now we have something known as a type of topology change. Type of TCN. We will discuss more. Types of TCN.
TCN is topology chain, right?
Topology change notification. So we have seen like there is a two type of BPDU. One is TCN, one is the configuration BPDU, right? Configuration we have seen like a lot of information is sending, right? Okay. Uh, then we have a couple of topology change, scenario kind of. So that we are going to discuss. So that is means we have a couple of topology chains which could be happen in the network. Okay. So first we are calling as a, I will not go much deep dive on this scenario because it's I'm not people is asking more dive deep for as a network engineer. Okay. Some of companies asking might be, but yeah, that's fair enough. We will explain whatever we are going to discuss. Okay. So insignificant change. Insignificant topology change. Insignificant topology change. And then we have the second one is like direct. So topology change. Third, we have indirect. This question they are asking, but I will tell you what is the like, what will be the way how they are asking. Okay, you are learning, right? I will ask anytime question. Okay, so keep all those things remember and wait for my when I will ask you need to answer all the questions. That is mean actually. If you are unable to understand, then it will be difficult, right? To answer front of interview. You can relate the videos. So once you will read the video, you will understand all of this. So I'm going on actual scenario here. So let me remove all. So insignificant change means I will show you each and everything. Just try to understand. I'm trying to explain you guys. You have a PC connected, right? And one PC is connected here, for example. So how packet flow will be? For example, if it is pinging like 1.1.1.2, okay, and this system is like this IP is 1.1.1.1, and this system ping IP is 1.1.1. Right? So this is pinging like ping what 1.1.2. So how it will be happen? First, it will encapsulate the packet. System will encapsulate packet. It will reach here. Then PC, I mean switch will see what is the destination MAC address, where you want to ping, where you want to go, right? Then it will add the source MAC address like PC itself source MAC address, the destination MAC address will be this PC, right? So in that case, source MAC address will be this one, and because initially you do not have like ARP resolved, then in that case it will put the app as a broadcast, you know, MAC address, and then it will forward to this PC, right? And once you will receive the ARP reply and frame is completed, after that it will start sending the information, right? You learn all those things, right? I have discussed that each and every packet ARP, how ARP is working, and how traffic is flowing between those pieces, right? So now that all the PC, all the packet will go to root bridge first, and from root bridge it will go on PC. If you have other things as well as a network, for example, in that case also it will go like to here, then might be will connect it to somewhere else, then it will go like that. It's depend. Like root bridge is nothing but is a point of contact for each and every non-root system. Okay, so if something went wrong with this PC, for example, this PC went down. Okay, in that case, some topology change happen in the network. Okay, so this type of change we are calling as an insignificant change in the network. You got it? You have two PC connected, no matter where is connected, but in same spanning tree topology. In that case, any end user went down. Then in that case, topology change will happen. So actually, topology change will happen means what? Might be keeping in your mind, right? So let's see what is happening once any PC went down, how packet flow will happen. I will explain, but I will tell you that this type of changes, I will tell you the solution. I will not go more deep, dive deep and make the like how MAC address is changing and all those things. I will explain thoroughly, but I will not go more dive deep. Okay. Let's see first. Connect some PC here. Okay, let's connect here. Why is Amber? Because it's running the spanning tree. Okay. So first configure here like IP address, for example, 1.1. Leave that one, whatever step is there. Then second PC uh, to 1.1.1.1. Then go on third PC, configure 1.1.1.3. Okay. Cool. Just fast forward something. Now I'll just enable the simulation mode and edit filters. So we required STP, where it is HTTP, and we required ping or ICNP. Just take it for some time. Okay. Three packet I wanted to capture. So I will repeat the things again, how it's working, and then you can. So ping 1.1.1.2, for example. Now, two packet will be encapsulated. One is ICMP, one is R, right? ICMP, I have write the ICMP, but automatic one R packet will be generated because ICMP packet is incomplete, right? That's what R is generated. So what are the information in the R? It's a layer 2 protocol. That's what is hand over on the layer 2. And then it keep the R packet, source MAC address, target MAC address, source IP address, and target IP address, right? So it's make as a put as a 000 and hardware version and all those things there. Then it will hand over to layer 2. Preemption you can see already. And then destination MAC address, it will put as a broadcast. Source MAC address, system MAC address itself, right? And type, as I explained already, that is R, then its type it is 0x0806. If we have IP packet, then the type will be like 0x0800, right? Okay, then this packet will be encapsulated and forwarded to next switch. For example, next switch. What switch will do? Switch always will, once it will receive the packet, I mean frame or whatever, then it will first build the MAC address table. MAC address table, you know already how it's building because it will ask by the interviewer how it's working. Okay, then it will build the MAC address table. It will see what is the destination MAC address. On the basis of that, switch will forward the packet. It will how switch is taking the forwarding decision on the basis of destination MAC address. Whatever MAC address you put in the destination, that MAC address will took into the MAC address table and take the forwarding decision, right? Then we have a case as a FFF, then it will forward to all the interfaces. For example, here as well, here as like see. Now it switch also build the MAC address table, like which port is receiving, what is the source MAC address, and blah blah. Okay. Then it will forward. This forward will accept the packet, this one will reject the packet, right? Because I am pinging this message, this system, so this system will receive the information like that. Okay, and now ARP is completed. Now you will see R20, you will see on the computers, right? Now this, this packet will go, I mean, communication packet, I mean, ICMP packet. Now you will get one reply from the ping reply, you mean to say that. If you will see in the computer, you will see one packet you have received as a ping. See, right? Now
Clear.
my concern is not explaining the packet flow. Okay. My concern is to see the spanning tree packet, how it's working, right? So what I will do, I will go ahead and shut down this interface. For example, I will go ahead and I will shut down the enable config T. Then we will see interface fa0/3 and shut down, right? Done. Now let's see what message is generating. ICMP, it's okay. Spanning tree. Now deep dive spanning tree. Spanning tree is a layer 2. That's what it will put the MAC address header in that, right? Let's go on deep dive and understand LLC. LLC is layer 2 header, kind of. It's Ethernet. A lot of information is keeping here. Okay, then LLC will hand over to Ethernet. Ethernet, same. Source MAC address will be added, destination MAC address will be added. And, this is a spanning tree BPDU, as I explained. LLC, this one LLC header, and this is spanning tree BPDU. You can see what are the messages we learn, right? Root ID, root cost. See, always is sending the zero cost BPDU, right? Because
Yes.
it's, yeah, bridge ID. What is the bridge ID? What is the port priority? Okay, port ID they are saying. Okay, message time, forward delay time, hello message, hello time, all the information which I have seen in, I explain like content of BPDU, right? All the message you can see here. Here you can see. If I can extend more. I don't know. Like that, a root port role and lot of information what you learn it will give, and after that it will hand over to layer 2 header, layer 2, LCC for Ethernet always is running, and then layer 2 header will be added, because this is the protocol is responsible to generate the header, I mean Ethernet. So you can see Ethernet source and destination MAC address. So destination will be always like, you know uh, what we call, uh, road bridge one. So if I cannot extend more here, let me see if I can do. Uh, I need to see here. You will need TCN something. TCN packet is generating. Okay. I'm able to see here because the role is here. Okay, I can see some copy paste or something. In pad, copy, copy, paste somewhere. This is only false. Just understand, like, this is something TCN BPD, you can say, or configuration BPD will, I unable to see that changes, but I what actually I wanted to see, I will explain you. So this is spanning tree, would be spanning tree, maybe spanning tree, configuration BPD, maybe TCN BPD. Let me explain. Once it's sending this one, both the switches. This one accepted. This one accepted because it's communication message. But I wanted to see one more message. See, actually, all the spanning tree message is going to end user as well. Correct? Means all the spanning tree messages is going to end user PC as well. But that is required. I don't think so because PC does not understand about the STPs. Okay, it's more what the message is. Uh, Type of message I am unable to see here. That is one concern. But what will happen once any port will down? Then this switch will send a topology, insignificant topology change message to root switch. Like my topology went down, something. Then what will be happen? You will see, might be see the message or not. Let me see here. So it's penalty. So it's penalty. Okay. Messages should be so. Oh my. Actually, I cannot see here that message. Actually, what is happening in real scenario? So as soon as any topology change is happening in the network, then all the switches, the switch will reduce the MAC address aging time. MAC address aging time from 300 second to 15 second. Why is it happening? Because as per the spanning tree things, it will change their topology. I mean, they will convert their topology. Might be this port is down. Then they need to refresh their MAC address table. Okay. And then after that, they need to take a forwarding decision. If this will not be changed from 300 to 15 seconds, then 300 second, whatever MAC address is learned from this interface, is assuming some other same MAC address will come and we will forward the traffic. But it will keep this port is learning this MAC address for the 300. It will keep 300 second. Okay. Until unless it will not remove 300 second, the PC cannot forward their traffic. Okay. Means we need to convert the MAC address table as well as if any end user PC down, which is not required at all. Okay. In that case, then it will send the TCN BPDU, TCN then received by the root port, I mean root switch will inform to all other, it will also change their topology like from 315 second and then they will send to here and blah blah things will happen. Okay. So to avoid this, actually, give me a moment, I can explain in more. Okay. So as I said, explain earlier, like these non-root switches never send the TCN BPD, right? Remember, they will send always hello. Oh, sorry. It means non-root switch will send the TCN, but this switch, root switch always send the hello BPDU, and in that it will on the TCN flag on TCN bit, right? You remember last time we discussed like this non-root switches always generate the configuration. Oh, sorry, TCN. If any topology change will happen, then this root switch responsibility is send the configuration BPDU by changing the flag in the TCN. Okay, that is one case. And but when any switch will send the TCN BPDU and which switch will receive the TCN BPD, those switch will set their MAC address aging time. I cannot see that command because I cannot show you. Let me see. Let me try. So by default it's 300 seconds, but last time we were trying to see, but I was unable to get that. So MAC address. So my see the MAC address aging time. Sometimes it can show here as well, but I don't know because it's not a real switch or something. You cannot see that messages aging time how it's changing. If you have a real switch, then definitely you can see that MAC address aging time is reducing from 300 to second to 500 seconds. And so any whatever devices, I mean, this sending, they are not sending computer, they are not sending any packet. So those MAC address will be removed. Like standby, whatever MAC address will be there, they are not sending and receiving the traffic. That will, remove from MAC address state. Okay, we have a couple of advantages why is removing because unique, ununique cache removal and so on. But just understand, if any root, I mean, system port will down, then a TCN will be generated from this switch. Okay, this switch and TCN, and then it will inform to root trees, and root will be informed to some other switches, like some topology change happen. This message is not required to send to root switch because it's end user PC. It's down, no matter, right? No issue. Why switches are changing their topology? Right? It's not like a good practice. That's what companies are not using this in insignificant changes. They will remove this. So how you can solve this by enabling the, what we call port fast. We are calling as a term as a port fast. If you will enable, then whatever messages we are sending to end user PC, it won't be sent. So let me enable it port fast in each switches. Okay, and then we'll go ahead and do that. C surface FS0/3, no shutdown. Okay. Then port is came up. No worry. Now, what I am going to do, because you can see earlier, right? TCN, let me edit the filter. Only I will keep TCN, then remove this ARP and all those things. Now send the packet. Here, this is every time message is sending like TCN. This message is, this hello BPDU. They are each communicating to each other. Then again, you will see message every 2 seconds they are sending. Okay, because this is the root switch. They are sending to each other everything. These switches will not generate a message. Okay, so once you will see TCN, for example, just go here, not here, go here, and then enable config T interface FA0/3 shutdown. That right. Then as soon as we will shut down the port, one message will be generated. This message is sent. This message might, okay, which one? Okay, one second. TCN, let me see, I can see the message. It's difficult here to see the message, what kind of message is sending. TC, TC pulse, okay, here, PRO, protocols, listening, state, forwarding, edging, TCA flag. It's okay. Now we can see that. I think finished message or something. Let me see again. you can see message I cannot see here. Okay, just understand. Like, okay, what I explained.